When a hydroxyl group of a carboxylic acid has been replaced with a chlorine atom, the resulting molecule is known as an acyl chloride. Acyl chlorides undergo similar reactions to carboxylic acids, but are more reactive since the chlorine makes a better leaving group than the hydroxyl group. We came across acyl halides when we were working on aromatic compounds, with acylation of the benzene ring with an acyl halide using a halogen carrier in Friedel-Crafts reactions. Acyl chlorides can be made by reacting the carboxylic acid with a compound called thionyl chloride, SOCl2, where sulfur dioxide and hydrogen chloride gases are produced. An acyl chloride with one carbon in the chain would be known as methanol chloride, and one comprising of 2 carbons would be ethanol chloride, and with 3 carbons, propanol chloride, and so on. Once prepared, the acyl chloride must be kept dry, since acyl chlorides react readily with water to produce the carboxylic acid. In the same way esters are made from carboxylic acids and alcohols, esters can also be prepared by reacting together the alcohol with the acyl chloride in place of the carboxylic acid. Making esters with acyl chlorides does have the advantage over using the carboxylic acids, however, since the reaction is irreversible, unlike when the carboxylic acids are used and the reactions are reversible and an equilibrium is reached, and so the reaction does not go to completion. Also, it is much easier to make phenol esters using an acyl chloride rather than a carboxylic acid. Acyl chlorides will react with ammonia to produce a primary amide. A primary amide has the carbonyl adjacent to the amino group, the NH2 group. Similarly, if we place one of the hydrogens of the ammonia with an alkyl group, ethyl for example, we have the amine ethylamine, and this will also react with an acyl chloride to produce a secondary amide. A secondary amide having only a single hydrogen bonded to the nitrogen.